We're going to continue our talk on inequalities, and today we're going to do, I know, it's very noisy in here today.
What are you doing on your iPad, Jason?
Throwing them under the bus. All right, we're going to do 1.5b, compound inequalities. So if you got last night's lesson, okay, this won't be too bad. Now, compound inequalities are going to be a pair of inequalities, joined by either the word and or. Okay, a lot of times you don't see the word and. It's in there, but you don't see it. The word or shows up, though, a lot. So let's go ahead and do some of each. We're going to start with the ones that have and. Okay, so when I was reading the announcements this morning, I said, are you a boy? And do you want to play golf? So boys raise their hand, and then do you want to play golf? And maybe one or two. One.
Preston,
yeah. One stayed? Okay. So he was a boy, and he wanted to play golf. Both things had to be true, right? Okay, what we're going to do for these inequalities, we're going to find all the values that make both of the inequalities true. Okay? So I'm going to say something like you need to be bigger than 4 and less than 10. Can you think of numbers that are bigger than 4 and 6. Less than 10? 6 works, yes. It's a whole bunch of them, right? Okay, but they have to be both. Bigger than 4 and less than 10, something like that. So here we go. Let's do one. Number 1. And these problems, I didn't assign too many because you actually have 2 problems for each problem. There's 2 of them, right? We're doing compounds. Yeah. All right, we're going to solve and graph. Solve and graph. 7 is less than 2x plus 1. And 3x is less than or equal to 18. Okay, so these go together. They're separate problems. We're going to solve them separately, but we're only going to do the numbers, the answers, that make both of these inequalities true. Okay? So take the first one, and let's go ahead and solve this. This is pretty basic. You guys should be getting pretty good at these. We did some equations, some inequalities on this stuff. So subtract 1. 6 is less than 2x. Divide by 2. 3 is less than x. I know a lot of people don't really like that. They like the variable to go first, which is fine. So we can rewrite this as x is greater than 3. Okay, so that's half of it. So first of all, you're finding numbers that are bigger than 3. Now let's see what the rest of it says. Divide by 3 over here. X is less than or equal to 6. Okay, so my answer is going to be x is greater than 3 and x is less than or equal to 6. Okay, so you just solve them separately. It's like solving 2 separate problems, but it's really all together in one problem. And let's graph this answer. Okay, so x is greater than 3. Let me say that's 0. 1, 2, 3. X is greater than 3 is going to be an open circle around 3 going to the right. Greater than 3. But do I just keep going all the way to infinity? No. Yes, you got to stop at 6. 3, 4, 5, 6. And then I have to make sure that the numbers are also less than or equal to 6. So I'm going to put a solid dot at 6, because 6 is a good number. And it's just these numbers in between. Yeah. You like it? Do you hate it?
Yeah.
Okay. Oh, yeah, you like number 6. That's true. All right, number 2. Let's try another one. 2x minus 1. 2x minus 1 is less than or equal to 3x. So we're going to solve these inequalities of numbers x that work for this. And they also have to be x is greater than 4x minus 9. Okay? So you're going to take them one at a time, and then you're going to kind of combine the answers at the end. So let's do it. You ready? So for this one, what are we going to do first? What's our first step? Subtract 2x. Let's get our x's together and subtract 2x. And I get negative 1 is less than or equal to x. If you like that and you're satisfied with that, that's fine. I'm going to go ahead and turn this around and say x has to be greater than or equal to -1. Over here, let's go ahead and get our x's together by subtracting 4x to the other side. X minus 4x is -3x is greater than -9. Okay, we're going to divide by -3, and what are we going to do when we divide by a negative number?
Make it positive.
We're going to make this side positive, right? And we're going to flip the sign the other way because we're dividing by -3. Okay. So our answer would be numbers x that are greater than or equal to -1, and they have to be less than 3. Okay? Both things have to be true. So let's graph this on a number line. Put 0 in the middle. That's kind of boring. -1, 1, 2, 3. So x has to be greater than or equal to -1, so I'm going to fill in a solid dot there. And I'm going to keep going until I get to 3, which is going to be an open circle. It's not equal to 3. You feel pretty good? Pretty confident in your inequality skills?
Yeah.
I thought so. Number 3. Now I'm going to give you one that is an and problem, but the word and's not in there. Okay? Yeah, but it's actually better. This one's better. Here we go. -2 is less than 2x minus 4 is less than 12. Okay, this is two problems. It is. It's saying that this number, x, when you multiply it by 2 and subtract 4, has to be between -2 and 12. It has to be bigger than -2, but less than 12. Okay? So what we're going to try and do is find out what x is. We're going to find out x has to be between two numbers. So this is what we're going to do. We're going to add 4, and we're going to add 4, and we're going to add 4 to all the parts. There's 3 things in there, right? There's this side, there's the middle, and there's that side. And you got to add 4 to everything to keep it all balanced. This becomes 2. This is 2x, and that's 16. And now what do I got to do? Divide by 2. Divide everybody by 2. This side and that side. All of them get divided by 2. And you get 1 is less than x is less than 8. Okay? And you can keep your answer just like that. All is one thing. Okay? And when you graph this, here's 1. And there's 8. And x is greater than 1. See, 1 is less than x is less than 8. What that means is you go from 1 to 8, and x is all the stuff in between. There you go. And it feels like, I mean, you're doing 2 problems, but you kind of did it all at once, so it takes a little shorter time. Okay, part B. Now let's do OR. OR. Okay, and we've had OR things. We did greater than or equal to, and it didn't have to be both, right? It could be greater than or equal to it, and it still worked. So OR. We're going to find values that make at least one of them true. So if I tell you, hey guys, pick a number that's less than 3 or greater than 10. Sorry, 6 won't work there. Okay? So if people are going to pick less than 3, you guys are right. If other people are picking greater than 10, you guys are right too. Or, not both, right? Can you pick a number less than 3 and greater than 10? No, impossible. We're going to talk about those. Those are weird. -0. That does not work. All right, here we go. Number 4. We're going to solve and graph. Solve, graph. Still 2 problems. Here we go. 7 plus x is greater than or equal to 6. Or 8 plus x is less than or equal to 3. Solve and graph. 7 plus x is greater than or equal to 6, or 8 plus x is less than or equal to 3. So let's go ahead and solve these. Solve them separately, and then we're going to get the answer kind of combined in a way. So x is greater than or equal to negative 1. Over here, subtract 8. X is less than or equal to negative 5. Okay, so our answer would look like this. X is greater than or equal to negative 1. Don't forget to write the word or. X is less than or equal to negative 5. And then we're going to graph them. Now, the ones that we did before, the 3 that we did before, if you noticed, they came together. It was this way and this way. Ors are going to go the opposite. You knew that, Wyatt. Shout out to Wyatt on the video. All right, here we go. So let's say we have 0, negative 1, 2, 3, 4, 5. So x has to be greater than or equal to negative 1. That's right here. And its number's bigger going this way. Or x is less than or equal to negative 5. That would be numbers going that way. Okay? You've done these before. You did them in Algebra 1. You might not remember. What's that? You want to try one, Abby? Okay. Number 5. Yeah. That was what that sigh was, huh? I'm so tired of you doing them all, Ms. Price. Please let us do one. Okay, no problem. Here we go. 4x minus 2 is greater than 14. Or 3x minus 4 is less than or equal to negative 13. All right, you try that one. It's okay if the numbers turn out as fractions and stuff. No big deal.
Oh, so you get the pretty ones and then you get the nasty ones?
True.
Thanks.
Yes. So let's solve this. We're going to add 2. Oh, this one turns out okay. 4x is greater than 16. So x has to be greater than 4. Or let's add 4 to the other side. Oh, this one turned out okay. What was I thinking? Yeah. So what is that, negative 9? And then x has to be less than or equal to negative 3. And I'm just going to put an or right there and circle my answer. That's nice. All right, so did you graph it? Try to graph it. X is greater than 4, so I'm going to go 1, 2, 3, 4, and numbers that are bigger than but not equal to 4, or numbers that are less than or equal to negative 3. Who got that? Let's see. There's like 23 kids who got that one on the video, so you know. Okay. All right. Last part. Just in case someone's watching, they're like, how many kids got that right?
All of them.
No one cares, though. It's okay. All right, special cases.
Is this our last one?
It is.
Yeah, no.
And I got like 1 minute left, right? All right, special cases. Now, what happens if something like this happens? Numbers that are less than 5 or numbers that are less than 3. Okay, because sometimes they're not going to be nice. We want the ands to come together usually, and we want the ors to go apart. This one's saying, hey guys, tell me numbers that are less than 5. Okay, bless you. Or numbers that are less than 3. Okay? All right. Numbers that are, these go the same direction. It's a special case. It's a weird thing that happens. So if I wanted to say numbers that are less than 5 or less than 3, I don't need that or less than 3. The answer to this is just x is less than 5. Right? Because if you're doing or, you want one or the other. Well, if you just say less than 5, that takes care of the less than 3. All of those answers are in there. That's a special case. I talked about this a minute ago. What about numbers that are, what was it? Greater than or less than 10. Numbers that are less than 10 and greater than 12. Okay? If you were to graph this and you went to 10, numbers that are less than 10 and numbers that are greater than 12, do you see that keyword and? They have to have an overlap. Is there any overlap here?
They're running away from each other.
They are. They're running away from each other.
Number 11.
This would actually be no solution. Okay? Nothing works. I should put that on a quiz. Hey guys, pick a number less than 10 and greater than 12.
Draw a happy
Fail.
face in the middle.
Okay? So things like that, you're going to see some weird special cases. You could see two ors taking up the entire number line, things like that. So look for those. All right.